Hello, Nanya. I'm audible to you.
Good evening, sir. Yes, sir, you're
Yeah,
audible,
good
sir.
evening. Sir told me about your upcoming exams. So, how I should proceed with mathematics portion for you?
Sir, um, whatever, like, so did sir share the syllabus to you, sir?
Yeah, he has shared me the syllabus.
Sir, maybe we can start with the easiest chapters and proceed as much as possible before the exam.
Okay, okay. So you haven't done any chapter from mathematics portion, is it?
No, sir. Sir, I'm actually a biology student.
Okay. So, which chapter I can start? Wait, let me check the syllabus in that case. Easiest chapter. Okay, how's your math as per grade 10th?
I was pretty good. I'm pretty fine with the basic maths. Sir. Like
Okay,
the
you're
10th
good with
grade
basic.
maths, my fundamentals are strong. So if you like, I can learn quick also. So
Okay, so what we can do is, um, okay, I have given the syllabus. Is it like you have syllabus weightage, like which chapter weightage most in the syllabus?
weightage, I haven't checked it. So
Okay, so what we can do is either we can go with the sets and logic.
mm-hmm.
Let me check which topics are there in the set representing different ways, subsets, type of set, universal, finite, infinite, intervals. Okay, so I think today I can start with the set portion.
Okay, sir.
Okay, okay, any book you are having right now?
I mean, reference books, sir. Or
Yeah, like any book from where you can practice after the course.
yes, sir. Like there, there, I have an online course, sir. It's for IITs. It's called Sai Astra. So they have
Okay,
chapter-wise questions, sir.
okay, they have chapter wise questions. So, do they have sets and logic chapter?
Um,
Check once.
yes, sir. Yes, so they have something called set theory.
Something called set theory. Okay, that is more than enough. Like it's fine. Okay, so I'll be starting your portion with the set theory itself.
Yes, sir.
Okay, so what is set basically? If we go into the set theory, set theory is nothing but a branch of mathematics which basically deals with collection of objects. Okay,
Mm-hmm.
collection of objects. For example, this is set. Okay, you can call anything like a. You can say b. You can say this is just a variable we are using for the sets. So let's say I'm saying this is my set. Okay, when I'm saying okay, how you have to reprint? You have to put a curly braces. Okay, and what you have to say, what I told as a definition, set is nothing but set theory is basically branch of mathematics which deals with collection objects. Okay, these collections will be called as sets. Collection object mean to say I can have a, let's say, alphabet collections. If I say okay, you know alphabets, right? Alphabets basically a collection of some alphabets like A, B, C, D, right? We can say this.
Yes, sir.
So alphabets, like a box of alphabets, that is nothing but a set. Okay. So for example, if I ask you, there's a set. There's a set. When I say set, what it means? Collection. Okay, collection of something.
Mm-hmm.
Which kind of collection it can have? I will give the definition. Okay, I will give the characteristic of that set. Okay. For example, in this set, if I say I am creating a set, having alphabets, first eight alphabets. Okay, what then? What I mean? A, B, C, D, E, F, G, H. Okay, this is a set. Clear. I was giving definition or characteristic. What should the set contain? So I am saying my set should contain alphabets. How many alphabets? Like total 26 alphabets are there, right?
Yes, sir.
So it's up to me what kind of set I want to create. Okay, set can contain anything you want to. Okay, it's like you can say you can put a dictionary. You can also say it's a kind of dictionary also where you are putting something as a objects. Okay,
Mm-hmm.
so if I have to give a better definition for the set is nothing but a well-defined collection of distinct objects. Okay, set is collection of well-defined distinct object. Clear?
Yes, sir.
Or better, okay, leave it. Set is a well-defined collection of objects. Well-defined collection of objects. This chapter is a bit easy, so that's why I'm taking this for the first. Okay. Now the set. Okay, set can be a group of distinct things. Okay, it can be numbers, it can be letters. Okay, another book you like, another some words you want to put, you can also put. Let's say, give me set of some household. Okay, indoor games, right? That
Mm-hmm.
can become a set. Give me a set of outdoor games. That can become a set. Okay, give me set of animal names, right? You can call that as a set. Set of fruits we can say. So what can be the set? Like, okay, I'll just give some example also. Set of fruits, for example. Let's start with set of fruits. What it can be? Any fruit you want to take. Apple, orange, uh, what I can say, mango, banana, whatever. Set of numbers we can say. Set of natural numbers. So it can contain anything like 1, 2, 4, 5, 6. Okay. So these are some things. Okay. The set can contain anything, whatever we want. Notation for set is basically we just have to use the curly braces. Is that clear?
Yes, sir. Yes, sir.
If something is in a set, what we can say, it is a member of set. Is that clear? For example, here if I say, is banana a set of this set, like set of fruits? In
Not,
real it is, but the banana, is banana a member of my set, my fruit set?
no, it's not a
No,
member.
right? So those who are present in my current set, I can say they are the member of that particular set. Okay, so that comes up as a membership part. All right. So these are like, this is a very basic portion. What a set is. Okay.
Yes, sir.
Let me check as per the syllabus which topic. Like, okay, set representation of set in a different way they want. All right. So I'll just go with the second thing is representation of a set. Okay. So set can be represented in two ways. The first one is roster form. So I'll just go with that first. Mm, Representation of sets. Okay. So how we can define set? And in general, the set is shown in the form of what?
Curly brackets.
In the form of curly braces, right? This is how we can show. Okay, but there's a particular name. Okay, how I have to define the properties of the set. So first way is a roster form, right? What is a roster form? We'll discuss more about it. So basically, when we put the elements in the curly braces, right? All the elements you have to mention inside that. Is
Mm-hmm.
that clear?
Yes, sir.
Okay. So all yeah, the first one is roster form. roasters. Okay, roster representation you may call, or you can say roster form. In this way, what how we show all the elements to be shown in between curly braces. To be shown in between curly braces. Okay. Mean to say, if I want to say, give me the set of first 10 natural number, what I can do? I can
But
say, okay, this is my set. I will start putting 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. These are first 10. Okay, these are first 10 natural numbers. Is that clear? I have put all these in between two curly braces. So this becomes my roster form of the set. Is that clear?
yes, sir.
Any doubt you have till now?
No, sir. Also, yes.
All clear, right? Now the next form is important. Okay, what is that form? That is set builder. Set builder form. The set builder form is a bit what I can say confusing, because here instead of giving these values, what we are going to do, we are going to put the characteristic. Okay, what it should actually. Understood?
Yes, sir.
Okay, so how I will say this part? It means, for example, okay. So I will say this is my set. Okay, how I will represent this set here itself. Okay, but in another form, I will say my set will contain x. Okay, after this this is you have to put the colon and you have to tell what is x. What is the x? So I will say my x is nothing but a. Okay, but what is my a? Give comma and say what is a. So a is something which belongs to n. N is now natural number, right? Understood this part?
Yes, sir.
Okay, it should. Now if you see, if I say it belongs to natural number, you know natural number is from 1 to infinity, right?
Yes, sir.
So I have to again tell more property. What is the next property? Here I have taken the value of a, which is less than or equals to 10. So now this becomes the set builder form of this roster form. Is that clear?
Yes, sir.
All right. So, like, if I had to write this, how I will understand? Okay, I need. If you see, it is x. Mean to say there is some value of x. Okay, what it is nothing but a. What is a? A belongs to natural number. Okay, let's see what should be the value. A is less than 10 or equals to 10. Mean to say, what is the minimum value of A? I can start with that. So minimum value is 1 itself, right? So I'll be going to 1, 2, 3, 4, 5, 6, 7, 8, and 9, and 10. Okay. So this is what the roster form you will be getting of this set builder form. Is that clear?
So here in this set builder form, can't we just say like instead of writing x is equal to a and then a belongs to natural numbers, can we replace the a directly by x? Like instead of after the colon, can we just keep that x belongs to natural numbers and x is like
Okay, that can also be done. For example, instead of doing this portion, you can also do like, you can also say x belongs to natural number and x is less than and equals to 10. Clear?
yes,
Basically, in roster form, what we do, what is the summary of these two forms? In one format, I have to give all the elements which are present.
mm-hmm.
In another way, I have to give first what element I'm going to put and the property, what it should be. Okay, from where it should belong. Clear?
Yes, yes,
Okay.
yes,
So this is what we call set builder, because we are trying to create a set out of the given format. Okay, is that clear?
yes, 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 yes.
All right. Okay. All right. So I have these three questions. I have. Let me know if you can do this.
Okay.
just based on the things whatever we have studied right now.
So they should be written in roster form or set builder form.
Yeah, the you have to give these in the form of set builder form. Okay? You have to convert this into set builder form.
Okay, so for the first one, we can write S is equal to in curly brackets X colon X belongs to natural numbers where X like uh, 10 greater than X greater than 20, and we can close the curly bracket for the first one. And second one, same
Okay,
X.
wait. I'll just write the first one. Okay. So x is basically what is x? It should be a number which is greater than 10. Okay. So let's say x. Okay. It is a number. So it is belonging to n. It should be greater than 10. It means x is greater than 10 and. So in that case, you have to put x is greater than 10 and what you have to say? X is less than 20. Fine. So this is one of the roster form for this. What about the next one?
Um, S is equal to curly brackets X, and then X belongs to natural numbers, and X is greater than
X is greater than
25. Sorry, 25.
fine, fine. That's correct actually. So basically, you can do the same method for the last also. This thing you can also simplify in a normal thing. How you can simplify this one? You can write this thing as x is okay. X should be in the center. X either this side you can put 20 and this side you can put 10,
And
right?
okay,
Basically, this simplified method. And for the below one, you just have to keep. You can do the same thing. You just have to write here. You just have to remove this portion.
okay,
No, basically you have to put 25 over here, and you have to remove this portion. It will make the x greater than 25. Okay.
okay, got it.
So here you have to put 20 and 10. So I'm not writing below 2. Okay. I hope you understood this part till now. Okay. So here after type of set we did. Okay. Let's do different types of set. Okay.
Yes,
So now we come up with different type of set. Different type of set. If this problem open my screen. Okay, so basically we have generally three type of set. One is universal set, another is finite set, another is single set. Okay, so what this set means?
sir, I
Basically,
learned this before, sir.
you have learned this before.
Yeah, universal is that includes all different kinds of like
Okay,
characters, and single set has only one like object in the set, and a finite set has a it doesn't have infinite number of things, but it has like a finite number of like objects in the set.
okay. So basically, like we have too many type of set. Okay, for example, we can say we have singleton, okay, empty, finite, infinite, equal, equivalent, subset, proper subset, power set, universal set, and distinct. Okay, but as per your given syllabus, we have just three things: universal set, finite, and infinite. Okay,
Mm.
so we will try to focus on those three first. Yeah, so we have. So here you have type of set. First one is universal set. Okay,
Mm.
what is universal set? Any idea like what is universal set?
Feel like it includes everything. Uh,
Yeah, it includes everything. Okay, a universal set is set which contain all the element of the set.
mm, yes, sir.
Contains all all the elements of the set. Understood?
Yes, sir.
Okay. What about the finite set?
And like if we take a few things from the universal set, and we put them in one set, it's a finite set. Like
Yeah. Basically, look, finite meant to say it should have countable number of elements. Okay.
yes, sir.
The number of elements should be there so that at least I can count. So the next one is finite set. Countable element should be there. Look, Ananya, what I will do now, I will not take your class for very long hours. What you can do is, after teaching the whole this set portion,
Yes, sir.
relation is there, so I won't teach relation today. Try to solve problems based on the sets, okay? And tell me which problems you are not able to tell, so that if I have not covered that topic, I will cover that topic, okay?
Yes, sir.
And if topic is covered still you are not able to solve, then we will solve these that kind of problem like two or three, okay, example based questions.
Sir,
So that's a thing.
sir, if it's possible, can we do some questions in class also?
Questions in class also. It is
Uh,
possible, but
okay, sir.
okay, we can do. Better will be okay. Can you take classes in the morning?
Yes, sir. Actually, that's more preferable, sir. Um, I also have classes in the evening, sir. Like music class and other classes are there. So I was asking Manisha ma'am if we can shift in the morning itself.
Okay, so which time you will prefer for the morning classes?
Sir, anytime, sir. I wake up at 5, so anytime after.
Okay, so what we can do is in morning.
Sir, except,
Okay, at 11 we can take, right?
yes, sir.
Okay, so what I will do, I will be taking your class at the 11. Okay, whatever topic I taught you, you can try problems based on that. Okay, if you feel like you are not confident and you're not able to solve the problems based on that, then evening I can take the doubt solving class for you. Is that clear?
Yes, sir. Clear, sir.
So,
Sir,
yeah.
Sir, Sundays I have a class at 11, sir.
Sundays, like I won't be able to take.
Yes, sir. Uh,
I Yeah, okay. Like Sundays, I won't be able to take. I can do one thing like Saturday, I can take your 2 hours class. This is what I can do.
no, sir. It's in 6 or like 8 is fine. Like, it's good, sir.
Okay. Saying something, I think.
No, sir. I was saying that I won't be available on Sunday at 11 a.m. So that's
Okay, okay. You won't be available. That's fine. All right. So the next one is infinite set. Infinite mean to say, for example, in the first property, when I gave you this example, right? You can see I have written here as x belongs to natural number and x is less than 10, right? So here
yes,
you can see this provides a countable thing. Okay, this bounded my set. Okay, if I just remove this portion, what will happen? You just know one thing that my x belongs to natural number, right? But what how many values should be there? You will be start writing from 1, 2, 3, 4, 5, 6. But there's no property which can tell you where to stop. It means you're going to infinite, right?
yes, sir.
In that case, this set becomes your infinite set because whatever the value you are going to put comes out to be infinite. Okay, there's no boundation on those values. So I
Yes, sir.
can say infinite mean to say infinite set. Infinite set, it means uncountable. Uncountable number of elements, you can say. Okay, so this is what your finite infinite looks like.
Yes.
And now we have to do some operation on the set. Okay, properties of various operations on a set and Venn diagram. This is what we have to study next. So some properties comes up as union of the set. Okay, so the first property is union. What happened? Just give me 2 minutes. Okay, so now I'm going to go with the, what is that? Operations on set. What does this mean? Basically, now like you have a basic idea what is set, right? But what you're going to do with the set? So we have some operations. Okay, how we can use these sets? So first property is union of a set. What does this union word mean?
Joining,
What does this the union mean? Union of a set.
like joining addition.
Yeah, basically, I have to join things. Okay. For example, your set can be like, let's say I'm writing a set. A set is something like, um, let's say I'm taking 1 to 10 numbers. Okay, it is odd. 1, 3, 5, 7, 9. Okay, and B is what? 2, 4, 6, 8, and 10. Okay, so if I say I have to get the union for union we use symbol this. This is symbol for union. Okay, so if I'm writing A union B, then what it becomes? It will contain all the elements which are part of these two sets. Okay, so if I have to write 1, 2, 3, 4, 5, and dot dot, I'll put till 10. Is that clear?
Yes, sir.
Now just assume instead of this 4, I would have 3. Okay, so what do you think? Will there be two threes or single three will work?
Single three.
Yeah, single three, exactly. This is single three. Okay, if you see carefully, because this 3 comes out as a common part in both. Clear?
Yes, sir.
Okay, so when we study about the common things, when we try to extract out the common thing, it is called as a intersection. Okay, And there's something called Venn diagram. I will teach that along with this portion itself, although I will teach that separate also. Something called Venn diagram. Okay, what is Venn diagram? Venn diagram is basically the representation of the set. Okay, how we represent in the form of Venn diagram, basically Venn diagram. I will try to make the Venn diagram of this itself. If you see, this was my space, right? Let's say this is my some space. In that I had one element A, so I put some elements inside it. You can see my one, this A was containing one, two, no, what it was containing, 1, 3, 5, 7, 9. Is it?
Yes, sir.
There was B. It was containing 2, 4, 6, 8, and 10. Right? So this is how we can say this is A, this is B, and what is this? The whole thing is called as a universal set. It contains everything, right? It contains everything, on total elements, whatever you have.
Yes, sir.
Clear?
Yes, sir. Clear.
And we write U at the corner to show that okay, this is my universal set. Fine. Now, when I replace this B, this 4 with 3, it means there's one thing common. How we show that common part? Let's say this is A portion, where 3 is present. I can say this is B's portion also, where 3 is present. Okay. This intersection portion says that okay, this element comes out to be common. Whatever whatever there's a common in between, it will present here. So you can see right now we don't have any this kind of structure, right? It means there's nothing common in this. But if I say okay, I am removing it and I'm saying 3 is also present here. So how it would look like? It will look like this. 3 is present, 2, 6, 8, and 10. Understood? This
Yes.
is a common portion. What is this? You can see this is a common portion. Okay. When we try to figure out what is common in between, we call that as a intersection of set. Is that clear?
Yes, sir.
So just like union set, we have another operation that is intersection. And I think till now you must have got the idea what is intersection of set.
Yes, sir.
Intersection of set. So what this is? Intersection of set.
So
It is
this.
basically, yeah, okay. It is basically set of elements which belongs to both A and B. Set of elements, okay, which belongs A and both. Okay, so I'm just taking the same example, the above one, and you can put it over here. Like whatever value is given to you, A, 1, 3, 4, 5, 7, 8, 9. In the B, I'll put some random values, maybe 2, 1, 4, 5, 10, 11. Okay. So if I say what is the total, what is the universal set, it will become like this, right? Venn diagram of it will be shown like this. This is A portion, this will be B portion. We can make little bit big because we have more number of elements as a common part. So how many of them are common? 1, 4. I think 1, 4 is the only common elements, right?
Five also.
1, 4, 5,
Five.
3. Yeah, 3 elements we can put. Rest should be there. 3, 7, 8, 9. Okay, here we can put the rest of the elements 2, 10, 11. So this is what you think. Now I had to get the intersection. So this portion comes out to be the intersection. Okay, so how you have to show the intersection of set?
Upside
This is
down.
the way, right? So we will use. this. Okay, this thing. You can see in union I was using this U. In intersection I'll use this, the cutted portion. So what is the intersection of both? It is 1, 4 and the 5. Is that clear?
Yes, sir.
One more representation is there. Look, can I write it as A and B? Smaller and B. What does this and means? And means whatever the elements which are present in both A and B. Like one is the element which is in A and B. Four is the element which is in A and B. Five is the element which is A and B. Okay. If I take three, it is in A, but it is not in B. So I can't put. So I can say one, four, five. Understood? So look, now you understood that if it is written and between two elements, okay, in this set section, you can understand that it wants me to get the intersection of the element. Is it clear? Ananya, is this clear about the end part?
Yes, sir. Please, sir.
Okay. Now, one more thing. When I was saying union, okay, how we can represent the union without this U and this reverse U? We can use or in that case. Okay, if for the same thing, I can replace this with the or. Or mean to say, I this element can either be in this B, either it can be in A. Okay, you just have to put it over. It doesn't matter. It doesn't matter. It should whether it is present in both or any one of them. Okay. If it is written or, you have to give the union. If it is written and, you have to give the intersection of the set. Is that clear?
Yes, sir.
Okay. So these are two important properties of a set, like operational properties of the set. Okay. Let's go to the next operation, union intersection. The next is disjoint set. Disjoint set. What does the disjoint set means? By the name, if I ask you what does the disjoint set mean, basically, for example, if you see, when I took the first example here, when nothing was common, right?
Yes, sir.
So that is called as a disjoint set. When you don't have any common element, sets having no element is common, no common element. Okay, so if you have any set which don't have any elements as a common, so we can call it as a disjoint set. And I'll be representing most of the cases of Venn diagram. You can see this A element, it might have some element. It is B set, it might have some element, but there's no element common, right? You can see if something shown like this, then only I will say, okay, this is common. But here you can see I haven't shown anything which is common. Is that clear?
Yes, sir.
All right. So this is about the disjoint sets. Okay. One more thing. If you calculate A intersection B, what you are going to get? You are going to get null. Basically, you have to create a set, but it won't contain anything. Understood?
Yes, sir.
Either it will, like, you can represent by this or you can represent by 5. Mean to say nothing. You don't put 0 because 0 itself an element. It can be a part of element. Okay. So you have to either put this or this part, the null. Okay. Mean to say it doesn't have anything. It doesn't contain anything. Okay. Tell me if you have any doubt till now.
No, sir.
All right. Let's get back and try to calculate some formula based on this. Let's start with the union first. If I ask you, if I ask you that A contains 10 elements, B contain 5 elements, and the common is C. Let's say the common. Okay. And if I say total elements is 12, can you tell me how many elements are common in between?
Yes, sir. Three. So there will be two.
It should be.
Three.
Okay. So there's a formula how we can calculate this. Okay. I will try to make a formula which will fit in both union and there will be a relation between two set A and B and union and intersection. Okay. So let's create the formula below. You know this is one set, right?
Yes,
Okay.
sir.
This is another set. If I'm saying this is A, this is B, you know that this portion is an overlapped portion, right?
Yes, sir.
Can I say this part? It means if I add A and B, A plus B, I am covering this portion twice. If you could understand, I am covering this portion twice. How
Yes,
I
sir.
am covering twice? Let's say total A and B because let me remove. Let's say this was like this. Okay, due to A, due to A, it had two elements like 1 and 12. Due to this B, you had two elements 2 and 1, right? So if you add 1 and 2, what will happen?
Like
First time, these two elements will be covered in the process of A, and another time, this two one will be present in the two, right? So you can see you have counted this time extra, right?
yes, sir.
The whole intersection portion you have counted extra. So to get the total number of elements, can I say I have to subtract the intersection portion?
Yes, sir.
Okay. If I do what I am going to get, I will be getting union, right?
Yes, sir.
So this is your formula. How you can use this? A very simple idea. Now you can see you have got your formula A union B. What does this A union B is? A plus B minus A of intersection of B. Okay, now you can just replace whatever you want. Let's say you have given this, you have given this, you have given this, you have to calculate. You can calculate, right?
Yes, sir.
Okay, you can see in the previous question I was given 10 5 and I said the common element you have to calculate the common element, right? In this example which I give you,
Yes, sir.
maybe here.
Thank you very
Okay,
much.
that time you calculated common element is 3.
Yes,
If
sir.
you do this, you will get the total element to be 12. And I that time instead of giving this, I told you the A is 10, B is 5, the total element is 12. You have to calculate A union. Okay, so you can apply this formula. Understood?
Yes, sir.
This is a normal thing. If it says you have give me the number of elements, in that case you can say okay, number of elements in A union B equals to number of elements in A, number of elements in B, number of elements in A intersection. Is that clear?
Yes, sir.
Okay, so these are the things which is a part of operation of a set. I hope till now it is clear.
Yes, sir. Clear.
Okay, if you see, we added, right? We did some addition of the sets. Now we come up with a set difference. Set difference is basically, if I say in here itself, let's write it as set difference. What does set difference means? Let's say I'm saying a minus b. Then how you have to subtract a minus b? It means this whole thing is going to represent something which contain all the elements except elements in the b. Understood?
Yes, sir.
For example, A contains 1, 2, 4, 5. Okay. B contains, let's say, 1, 2, 9, 12. Okay. So when I, okay, this is 20, right? I am saying A minus B. So first of all, put all the elements of A 1, 2, 4, and 6. Now figure out how many of elements of these present in the B and remove them. I will go and check. One is present in the B. Just remove it. It is not a part of set. Here it was two. Go and check. 2 is also present. Remove it. It was not a part of set. The rest 9 and 20, they are not a part of set. Leave it. So this is what your A minus B will look like. Understood?
Yes.
It is not necessary that all the element of B should be present in this. It may be the case that your A is empty, B have too many elements. Basically, you just have to take care of that. All the elements which are present in A and B should be removed from your final set. Understood? Or you can say that in the given set, the set you are going to get, it should only contain the element which is only the part of A. Okay, should not be the part of B. That is what we can say. You have to remove all the elements which is present in the B and put that into this set. Any doubt you have? Ananya, any doubt you have?
Can you hear me?
I don't know. I'm saying, do you have any doubt?
Yeah, no, sir. I was speaking. I think I couldn't hear. I was asking, sir. In the Venn diagram, like in the diagram, is it like uh, uh, only the part of A will be shaded, but the common part will not be shaded, and B will not be shaded? It will be like that.
Okay, for the set difference thing.
Yeah, yes, sir. It's a difference.
Okay, look, set difference is basically it's saying, first of all, if I just hide this portion, if I try to hide this portion, leave it. I can't hide this part right now. Okay, if I just remove this portion, what is given to you? The question said, give me the A, right?
Yes, sir.
It says, give me the A. So I will say, okay, I'm giving you A right now.
Yes, sir.
Okay. So let's say you gave, okay. I gave A over here. Then question says, subtract something from it, mean to say remove that element.
Yes, sir.
So I'll remove that first. It says remove B. Now B has too many elements like 1, 2, 9, 20. I don't have to take care of how many elements are there. Just remove all the elements of B which are present here. Okay.
Yes,
Doesn't matter whether they were present in A or not. I don't have to check. I put all the elements of A. Now I will try to remove all the elements which is present in the B. So I will go and check. One is present, remove it. It is not part of it. 2 present in B, remove it. 9 present in B. Okay, it is not present in A, doesn't matter. This is 20. Is it present in my set? No. Okay, that is fine now. So this is how we can do. It should contain, it can contain anything. Okay, it should contain A, but all the elements which is also present in B should not contain. Is that clear?
yes, sir.
Okay. So why I'm not directly calling, you can say that you just have to remove the intersection part.
Yes, sir.
Okay, so that's the thing.
Sir, can you draw the like the diagram for this? Uh,
For
circle.
this one, okay, okay. So this is, let's say, this is A portion. Okay, this is B portion. I want to show A and B. So this will be your A and B. A minus B basically. Shaded portion.
Yes, sir.
Let's call this as A. This is B. Okay. This whited portion I'm not taking into my box, and the shaded portion is I'm considering. Okay. I have taken whole total A, removed those which is a part of intersection. Is that clear?
Yes, sir. Clear, sir.
If there was no if there's a case when I don't have any intersection with B, so I could have removed this circle. Maybe I can remove, yeah, I could remove it, and I can say, okay, this is B itself at a separate thing, and I will take whole A because there's nothing common, so I don't have to remove anything from A. Is that clear?
Sir, and one more thing, like if A was a circle that's completely inside B, like their circles A is
Okay,
inside B
okay,
completely,
right.
then
Wait. You are saying that B is like this, right? The bigger box is B.
yeah, yeah, yes, sir. So
So
then A
basically,
minus B would be a null, like
it,
would be,
okay, it won't contain anything because A is inside B, right? And you want to remove the B itself, so the final will contain nothing. Understood?
yes, sir.
If let's say you are saying this is A This is B. So whoever present in this part, you just have to remove them. Okay,
Yes, sir. Yes, sir.
understood what it is?
Yes, sir.
Like I'll say, if you use the this Venn diagram thing, it will be more helpful than just putting these values.
Yes, sir.
So that's the thing. Another thing is comes out as symmetric difference. Okay, so what does the symmetric difference is? I think here I can write symmetric difference. The only difference between this and that is, you can, the whatever the elements you have, it can contain A, it can contain B, but it should not contain the elements which are intersection of both. Understood this part? We represent symmetric as A delta B. This delta means symmetric difference. It means if I have A, if I have B, so it should contain this portion and this portion, but should not contain this A portion. Understood this part?
Yes, sir.
It's just an easy thing. If there is nothing intersection, so A and B both can be there. Just figure out what is the common and remove that from your final set. That will give you the symmetric difference set. Is that clear?
So it's kind of like A union B minus A intersection B, right?
A union B might, no, no, there's a difference. When you do A union B, what will happen? Okay, okay, that's fine. That is fine. You can do A union B minus A intersection B. Okay, that's fine. You can do this also. All right. So the next thing comes out is complement of a set. Complement basically the opposite of the set. Understood? What I want to say is complement is complement of set. Let's say A is this. Um, let's not show it like this. If you see, this is my Venn diagram, right? This is A. This is B. Okay. Complement of A mean to say take everything except A. Understood?
Yes, sir.
Take A except A mean to say if I remove it, what you can take this, 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 and this. Okay, you can see I have just removed the portion which is part of it.
Yes,
Understood? So this is the thing. Whatever like complement is there, like if any some expression like A intersection B is there. So if I am saying remove A intersection B, like if in A intersection B is there, and I'm saying this, what does this mean?
complement of it. Everything except.
Let's let me remove. Okay, now I'm saying I'm going to take complement of this whole thing. So it means what was A intersection B? This portion was A intersection B. Just shade it out. Whatever you are left with, unshaded, take that. Understood?
Yes, sir.
We mean to say this portion you can take because it is not a part of A intersection. Understood?
Yes, sir.
Same you have to do for the like whatever you have given to. For example, any some expression is given, okay, and it is telling you to complement of that. First figure out what is that expression. When you figure out that expression, just reverse it. Okay, accept that, take everything.
Yes,
If
sir.
nothing is like if after removing that expression, if you have nothing, so make your set like this, empty. Clear?
Yes, sir.
So yeah, this is the thing. And various properties of operation of set. Venn diagram we have, okay, Venn diagram, any doubt you have? Like I
No.
tried to cover the Venn diagram portion in the here itself.
Yes, sir. All clear, sir.
All clear, right? I'll just check something. Okay, subset thing I have not taught you. I'm not sure whether it is a part of your syllabus or not. Okay, subsets is there. Subsets is there, so I will just go with the subsets last. some laws are there for De Morgan's law. Maybe I can go with the subset first, then we will go with the
So
De
is it
Morgan.
similar to the laws in semiconductors that we learn in physics?
What?
De Morgan's law, I think we learn
Yeah,
it.
it is also there. It is also there. Okay, when you are studying that Boolean logic, na,
Yes, sir. Yes, sir.
there you will be getting the that also. Okay, as a formula. Okay, so what is subset? If you see carefully, I got something set, right? And if I'm adding sum, what does this mean? Basically, a part of your set. Is that clear? Subset is basically a set which can contain some or all the elements of the set. Understood?
Yes, sir.
For example, if I'm saying I am having something like A, okay, A has one, two, three elements. So what can be the subset of it? One can be the subset of A. Okay, one, two can be the subset of A. One, three can be the subset of A. One, two, three can be the subset of A. Okay. You can't say that if I write a 3 1, it is another subset. Okay, it doesn't matter. Order doesn't matter. Just the element matters. Okay. So you
Yes.
can see I have made the 3 subset. Any other subset I can make?
Only two, only three,
Yeah, only two, only three, right? Three, three, six. And anything else I can make?
two and three.
Yeah, two and three. Okay. So, okay.
That's it, sir.
This is like this. This is one, two, three. When I took, I have to put it like this. How many sets we have made?
Seven.
Three, two. Okay, seven. Okay. And one more thing we have left over there. That is empty set. Like you have, when I said subset mean to say you can take a single element also. You will like it's up to you. Whatever you want to take the combination. So one combination also there that you don't want to take any element. Is it?
Yes, sir.
So it is also part of set. So you can see I had only three elements, but I'm able to make how many subsets? One, two,
Eight.
three, four, and whatever the elements you have. Okay. So I can say total number of subset. There is a formula for total number of subset. What is that? Subset. What is that? 2 to the power whatever the number of elements are there in your set. Understood?
Yes, sir.
So if you see in my case, I had how many elements were there? Three elements. So if you put 2 to the power 3, what you are going to get? 8. You can count out, you will be having 8 elements. Okay? Including 5. In this 8 element, this 5, basically the null is also present. Basically the empty set. Is that clear?
Yes, sir.
This is 8.
So is
Any
there
doubt you have?
is
Yeah.
there derivation for the total number of subsets, or
Your voice is a bit low, I think.
sir, is there any derivation for the total number of subsets, or
Okay, derivation for the total number of subset. All right. So let's start with how I can make my set. Let's see. Let's go with A. Okay. And I want to build subset. How many subsets I can build? So you can see I have only three elements, right? And I want to build. So what is the option with this element? Either I can take this element in my set or either I can't take, right?
yes, sir.
So if you see for each element, choosing or not choosing, only two options I have. So how many options I have with single element?
You'll have two options. So yeah, I got it, sir.
Understood? So I can do two options. Either I can take this or not. Either I can take this or not. Either I can take this or not. Right? So for
Yes,
each element, I had two operations associated. Okay. So if I'm choosing this, for example, if I choose this as one, so it can with one I can have rest number of things. If I don't choose that, like it is not there. Okay. I have a rest number of things. Okay. Again, if I choose that, I will be having rest number of things. If I don't choose, again I have rest number of things, right? You can see. So for
yes,
each two, I can have like for each two condition, can have rest number of things. Like here, if I am here, I'll be having another two, right? Another two and rest number of things. So can I say it is two into another two conditions can be there,
yes.
another two conditions can be there, so on. So this is how you can say you have two to the power n. Any doubt?
No, sir. Yes, sir.
Basically, it's about whether you want to take the element for your set or you don't want to take your element for the set. Is that
Yes,
clear?
sir. Yes, sir.
Okay, so you do you have any doubt in the subset part?
No, sir.
No, right? Now, subset of a real number. Okay. Okay. So how the subset of a real number looks like? Basically, you have natural numbers, right? Which comes from 1, 2, 3, 4, 5, 6. If you go just opposite side, basically include negative number. So I can say that natural numbers are subset of integers. Can I say that?
Yes, sir.
Also, if you see, if I include whole number contains zero. So can I say my natural numbers is a subset of whole
Well,
number?
yes, sir.
Whole number is an integer subset of integers.
Yes, sir.
Integers is a subset of rational numbers.
Yes, sir.
Okay, what do you think? Will irrational number comes in between the any part of this?
Uh,
No, right?
no,
Because
it
if you
won't.
see carefully, number comes up in different section. Okay,
Yes, sir.
its properties are different. So I can say, okay, irrational number is something else. So I can make a Venn diagram for this, which will look like this. Okay. First, I'll directly write irrational number here in a bigger block. I'm writing that as I and R. I and R. Okay. Here I have first is natural number. Then I have W as a whole number. Then I have integers I. Generally, integers are shown with Z. Okay. And the last but not the least, I have real numbers. Understood?
Yes, sir.
Real. And the whole thing comes up in the complex number, but you have not studied, so I want to include over here. I think it should be clear for it now.
Um, so just a doubt, but shouldn't irrational numbers also be a part of real numbers?
Which one?
Irrational numbers would also be a part of real numbers or no?
No, irrational number can't be part of the this thing, right? Look, if you see carefully, the whole thing is written as a portion of real number, right? All the below things are a part of all these below things are a part of real number, is it?
Yes, sir.
And if I say, does the relation between R and IR, like you can't like look first of all, R and I are very different thing, right? Real numbers and okay, what is it? Rational number and irrational number are two different portions.
Oh,
Okay,
wait. I got it, sir.
understood the point? So
So,
that's why I can't say that IR may be a part of it. I can't say that thing.
sir, but irrational numbers would be a part of real numbers, though, right?
Yeah,
No?
it is a part of real number. Okay, I should write the whole thing. And the whole this universal block. Okay, this is your real numbers. Clear?
Yes,
Real numbers. This is a rational. Okay, don't call it as a real. It is a rational.
yes, sir. Got it,
Under-
sir.
And the total thing is a part of real numbers. So I
Yes.
can say universal. Your universal set is what? Real number. In this universal set, you have two different set. One is irrational number, another is rational number. In rational number, you have different sets. For example, integer, whole number, numbers. Clear?
Sir, I have one more doubt.
Okay.
Sir, other than irrational numbers and rational numbers, are there any other real numbers?
Any other real number mean to say?
Like, uh, sir, whichever number is not, which is real and not
Okay.
rational, it would be under irrational numbers, right? Like,
The
can
number which is not real.
no, the number is real number,
Okay.
but it's not rational number.
Yeah, exactly. It will come up in the irrational
Yes.
number. Okay.
So, sir,
Basically,
so, sir,
look. For example, look when you go into the real number. Okay, you can see it's a kind of house. Okay, it's a kind of house. You have a real number as a house. You went into two portion. Okay. Now you said one person is there who is real. Mean to say who should be go inside real.
mm,
Now he have two options. He can either go rational. He can either go irrational. When you said he is irrational, There's no point on going this side, so he will go in this. Is that clear?
So my doubt is here, around the irrational numbers, there shouldn't be a circle, right? Because like everything that is a part of real numbers that's not rational would come under irrational. So there's nothing beyond irrational and rational. So there should not be a circle around the irrational numbers, right? And I'm just asking,
There should not be. No, no, it should be actually.
like, but
Like if look,
everything,
if I write, if I remove it, it
yeah.
becomes a universal set.
Oh,
Understood?
but
Basically, you have universal. Okay, you have universal. In that, you had two different houses, which are I, which is R. Okay, this is rational. In this rational, you have Z. In this Z, you have W. In this W, you have N. Okay,
yes,
now you're
that
saying.
part is clear, sir. That part, rational part, I understood, sir. So, but like,
So, like your doubt is, if I remove this rational part, if I remove this circle from the rational part,
hmm.
basically, if something which is not a part of rational can go in the universal, this is what you want to say, is it?
Yes, sir. So, like, if you put the circle around irrational numbers, it's like, isn't it like there is rational numbers, there's irrational numbers, and there's something else also, which is not rational and irrational, and that's part of real numbers. It doesn't it look like that, or is it not like that?
No, it is not like that. Basically, like we have two things. We have to define these two things. Okay,
Yeah. Okay, sir.
if something is there, like look, first of all, this is a universal thing. Okay,
Yeah. Yes, sir.
in this universal thing anything can be there. Okay, so we have just identified two things. If these two are not a part of this, we can say it is a part of here. Clear?
Okay. Yes, sir.
Okay, when you write universal, it means it can be anything inside it. Okay, it is not necessary it should be here, it should be here, it can be any place, but it is present inside that.
Yes, sir.
Understood?
But so from this we can't say that universal set, the difference of universal set and rational numbers is irrational numbers. We can't say that, right?
What we can say?
Like from here, from this Venn diagram, universal set minus the rational numbers would not be equal to irrational numbers. There would be something else also along with irrational numbers.
Complex numbers are there, no?
Okay, yes, sir.
Real numbers are not a part of complex numbers are not a part of real numbers,
That's what, sir.
right?
If we
It
take the universal set as real numbers, then
Okay, okay. Basically, whatever I have taken, this Venn diagram can be little bit more extended. For example, I can make this real number as one circle. Okay,
mhm.
I can make another circle. You can say imaginary numbers here, and I can say this. This is the biggest circle, and we'll call it as a complex number.
Yes,
Clear?
sir. Okay, sir.
Now this contains every kind of number which you can imagine.
Yes, sir.
Understood? Like you know what is real number, what is imaginary number?
Yes, sir. I
Okay,
don't.
you understood, right? So you can see now it can contain everything, whatever you want.
Yes, sir. I got that, sir. Mm,
Okay, so I think is it clear about the?
yeah, yes, sir. Clear, sir.
I can remove this for right here. Okay, so let's say some number is there which is not a part of your rational number and irrational number. So where it should go?
It should be a part of complex numbers. In
Uh, no, like right now I'm to real number. Okay, we don't know about the complex right now. Okay, complex I will say only when I make a bigger part. Okay, complex you can't say right now because complex is nothing but it is composed of two portion, real plus imaginary, right?
yes, sir.
So I am right now, I am into here. So there's no point of saying that in real I will find complex. No, it is not possible. Understood
Yes,
my
sir.
point?
Yes, sir.
So I am into a real number right now. If I say I have some number A which
Mm-hmm.
is not here, which is not here.
Mm-hmm.
So where it is? You will say, okay, it should be here something, right?
Yes.
But do I have any property for this portion?
Mm. No.
Nothing, right? So it means there's nothing which can exist either as rational, either as irrational. The number should either be rational, either should be irrational. Understood?
Okay. Yes, sir. I understood,
When
sir.
I say imaginary now, what happens is the same thing gets copied. Let's say the whole thing I'm calling is R, okay? And if you combine this R with I, you will get the total is imaginary part. Is it clear?
Yes, sir.
Right? And the whole thing will become complex. At the end of the day, this safe portion, it doesn't have any characteristics, so it means nothing.
It's
Understood?
a empty set, sir.
It's an empty. It's a you will get an empty set. There's no element which exists like this. Okay. When we build this, this is meant to be houses. Okay.
Yes, sir.
These are meant to be the sets. And we when we make like this, it's basically a space where I am deciding my sets. Okay. Outside these houses, there's nothing. It's an empty thing. Okay.
Yes, sir. Yes, sir.
All right. So um, okay, representation of set is completed, subset is completed, different type of set, universal, finite, infinite completed, various operation of set, properties of set, Venn diagram completed. Okay, so yeah, like some main portions has been completed in set. Okay, let's more talk more about the set. Basically, we have two type of set. One is proper set, one is improper subset. Okay, basically subset. Two types of subsets are there. One is proper subset, another is improper subset. Okay,
Yes, sir.
if it is a proper subset, what I will meant by the proper subset. Proper subset mean to say it is a part of subset, mean to say it is not equals to the element itself. For example, if you see carefully, when I made number of subsets, if you see 1 2 3 is there, right?
Yes, sir.
But isn't it the element itself,
Yes, sir.
right? So isn't it the element itself? So can I say it is a proper subset? No, it is the element itself. You can say it is a subset, but it's not a proper subset. Proper subset should be less than the element itself. Is itself clear?
Yes, sir. Yes, sir.
All these, the rest of the things are proper
Proper
subset, but
subset.
this is not the proper subset.
Yes, sir. Got it, sir.
Clear? So this is the very simple thing. Improper subset is what?
Everything that the element itself will be the improper
The
subset.
element itself. Okay. The improper subset is basically the element itself. All right. And what about the superset,
So something that contains the set.
which contains your A also, and which contains more than A also? For example, I have a B.
Mm-hmm.
Okay. B have one, two, three, four. Clear? It
Yes.
has it has A also. It has some elements other than A also. So B becomes superset of A. Okay, clear? A
Yes.
becomes proper set of B. Can I say this?
Yes, sir.
All right. Let's say if I give some name to this element, this A to C. C. Let's say I'm giving the name is C. So can I say C is a proper subset of A?
Yes, sir.
I can also say A is a super subset of C,
Yes, sir.
right? Because A contains C itself an element more than C. So I can say A is a superset of that thing.
Yes,
Now
sir.
I think it is clear for you like how we should solve this problem.
Yes, sir.
Okay. So look, this is the basic thing about the sets. I will say, I will prefer you to solve the problems. And okay, will you be able to take tomorrow morning class?
Tomorrow morning, at 11 a.m.
Yeah, 11.
1 second, sir.
Okay, look, whenever you will be like able to take class, just message at least 1 hour before. Okay.
Yes, sir.
Okay, and try to solve all the problems and give me doubts, whatever your doubts are there.
Yes, sir.
Okay. All right. So yeah, that's all for the day. If you have any doubt, let me know, or else we can do the class session.
So today's class is clear, sir. Like, I understood everything.
Okay. Basically, today's chapter was easy also. Okay, it's like you just have to read from the book. If you have book now, you can just read out the set and the definitions better. You will understand. Okay. If you
Okay.
like this chapter is like even if you read the examples now, it will give you more than enough in it. Okay.
Okay, sir.
So that's the thing. Yeah. If like everything is clear, we can end the session.
Yes, sir. All clear, sir.
Yeah. So, goodbye. Meet in the next class.